To use L'Hopital's rule, we need indeterminate forms 0 over 0 or infinity over infinity. In this case, when x approaches infinity, we have natural logarithm of infinity is infinity. So we have infinity and 1 over x, when x approaches infinity, is going to 0. So now we cannot use L'Hopital's rule. First, we have to rewrite this function. So let me put f of x equals natural logarithm of x to power 1 over x. Next, I will take natural logarithm of both sides. So we will have natural logarithm of f of x. This is equal natural logarithm of x to power 1 over x. This is equal. From properties of logarithm, we can take down this exponent. So we have 1 over x times natural logarithm of x. So this is equal. We can write this natural logarithm of x over x. So now we can find the limit as x approaches infinity of natural logarithm of f of x. This is equal limit as x approaches infinity of natural logarithm of x over x. When x approaches infinity, we have in the numerator infinity and natural logarithm of infinity is infinity. Now we have indeterminate form infinity over infinity. It means we can use L'Hopital's rule. Limit as x approaches infinity of our function, it will be equal to derivative of function which is in numerator over derivative of function which is in denominator. Let me remind you, when we have derivative of natural logarithm of u with respect to x, this is equal 1 over u times du over dx. In our case, u is equal natural logarithm of x. So u prime is equal 1 over x. In numerator, we will have 1 over natural logarithm of x times 1 over x. Derivative of x is 1. So this is equal limit as x approaches infinity of 1 times 1 is 1, and we have x times natural logarithm of x. When we divide by 1, it doesn't change anything, so we don't have to write. This is equal denominator going to infinity. So we have 1 over very large number, so it means this whole expression going to 0. So now we can find the limit as x approaches infinity of our function natural logarithm of x to power 1 over x. We can rewrite this, that this is equal limit as x approaches infinity of f of x. F of x is equal natural logarithm of x to power 1 over x. So now I will use again formula that e to power natural logarithm of f of x is equal f of x. When we have the same base, we can skip this whole expression and we have only f of x. So this is equal limit as x approaches infinity of e to power natural logarithm of f of x. So this is equal. We can rewrite this from properties of limit, that this is equal e to power limit as x approaches infinity of natural logarithm of f of x. So this is equal, we just found this the limit is equal 0. Limit as x approaches infinity of natural logarithm of f of x is 0. So we have e to power 0. E to power 0 is equal 1. This is my solution.